Welcome back to Master Academy of Mathematics. Now this is the next video session on higher order ordinary differential equations. So till now, in order to find out the particular integral, we have used the right hand side. One is e power ax and the second one is nothing but either cos ax or sin ax. Now this is your third one if the right side looking like x to the power of k. So in order to get your particular integral, I just give you the procedure and we enter into the problems. The first step is the given higher order ordinary differential equation you just represent in the symbolic form, that is f of d of y equal to q. Then find out the complementary function yc by calculating the auxiliary equation f of m equal to 0. Then you are finding the particular integral yp equal to 1 divided by f of d of q, that is equal to 1 divided by this f of d you are representing in terms of 1 plus or minus phi of d of x to the power of k. So that 1 plus or minus phi of d you are taking to the numerator to the power of minus 1 into x to the power of k. So definitely this is going to use the principle either it is 1 plus x whole power minus 1 or 1 minus x whole power minus 1. So definitely you are converting that f of d in terms of either 1 plus x or 1 minus x. This 1 plus x whole power minus 1 uses the principle 1 minus x plus x square minus x cube plus so on, or 1 minus x whole power minus 1 plus x square plus x cube and so on. So just you do the simplification and calculate your yp and finally you are getting the complete solution which is yc plus yp. So this is about the procedure of when q equal to x to the power of k. Now let us have a problem. Solve dq minus 3d minus 2 of y equal to x square. So for this higher order ordinary differential equation, the right side it is looking like x to the power of k here, where k is nothing but 2. So for that I am using the third method. So before going to that, first you represent in the symbolic form. So that is symbolic form is nothing but f of d of y equal to q, where what is your f of d? It means d cube minus 3d minus 2 and q stands for x square, which is nothing but x power k, where k equal to 2. So once you get that value, now you are finding the auxiliary equation. The procedure is f of m equal to 0. So here d is replaced by m cube minus 3m minus 2 equal to 0, and with the help of calculator you are getting the answer 2 and 1. Only two roots you are getting. That means one of the root is repeated. So you can apply your synthetic division method. You can identify your repeated root, and that repeated root is nothing but 1. So roots are real and a few roots are repeated. Therefore yc equal to the procedure is c1 plus c2x into e to the power of 1 into x plus c3 e to the power of 2x. Now after getting that, you are entering into yp. The procedure is 1 divided by f of d of q. It is 1 divided by your f of d means d cube minus 3d minus 2, and q means it is only x square. Now I told you in the procedure that the denominator should be converted into 1 plus or 1 minus. In order to take that one, I am just taking the first constant term, it is common. So I am taking minus 2 is common. So what will be the answer now? 1. Better I am starting with minus. So here you are getting d cube minus 3d divided by, here it is minus 2. Okay. You just think about this one. Are you getting the same value? You just multiply minus 2 into 1. You are getting minus 2. No problem. Minus into minus, here it is plus. And here again minus is there. So you are getting minus d cube. Better you neglect this denominator. So 2 is cancelled, minus into minus, here it is plus. So you are getting d cube minus 3d. This is exactly same. This is of x square. So now I am writing minus 1 by 2, that I am taking to the numerator. 1 minus d cube minus 3d divided by 2, this totally to the power of minus 1, this is of x square. So it becomes minus 1 by 2. Now what do you think about this one? This is looking like 1 minus x whole power minus 1. As per the principle, it is 1 plus x value d cube minus 3d divided by 2. Next, plus x square d cube minus 3d divided by 2 whole square, and plus so on. This is of x square value. Now here it is equal to minus 1 by 2. So just you do the simplification. 1 plus that 1 by 2. I am just writing d cube minus 3d, and plus it becomes 1 by 4. So a minus b whole square type. It is a square means d to the power of 6 plus b square is 9d square, and minus 2ab minus 6d to the power of 4, and plus so on. This is of x square. Okay. Now before substituting that value, first you roughly calculate d of x square. What do you mean by d actually? D stands for it is derivative. So just you are calculating the derivative. The derivative of x square is 2x. Similarly, if I write d square of x square, second derivative of x square, what is the answer? 2. What about d cube of x square? Third derivative is 0. The rest of the remaining derivatives all are equal to 0. So that value I am substituting. This is equal to minus 1 by 2. You keep as it is. It is 1 into that x square value. It becomes x square plus 1 by 2 as it is. What about d cube of x square value? It becomes 0 minus 3 into d. 3 into d of x square value. It is d of x square value is 2x. So that you are getting 6x plus 1 by 4. Look at the next term. D to the power of 6. That term is 0. Plus 9d square. D square is 2. So it becomes you are getting 18 minus 6d power 4. Its value is 0. Similarly, you are getting the remaining terms. Now just you do it. Minus 1 by 2. It becomes x square. It is minus 3x. And that becomes plus 9 by 2. So this is your final simplification. This is the answer of your yp. Therefore, you are getting y equal to yc plus yp. So this is the procedure how you are finding the complete solution when the right side looking like x to the power of k. Now let us have certain exercise problems on x to the power of k. The first one, d square plus d plus 1 of y equal to x cube. So directly find out your yc and yp x power k type. So you can apply the same procedure, and this is your answer. Y equal to c1 cos root 3 by 2x plus c2 sin root 3 by 2x, totally e power minus 1 by 2x plus x cube minus 3x square plus 6. Similarly, second one, d square minus 3d plus 2 of y equal to 2x square. Yc you can anyhow calculate. While finding the yp, 2 constant you can take it left side, and only for x square you are calculating this and making the simplification. Final answer y equal to c1 e power x plus c2 e power 2x and x square plus 3x plus 7 by 2. Similarly, d square plus d of y equal to x square plus 2x plus 4. So directly you can calculate your yc. It is c1 plus c2 e power minus x, and while finding yp, you just write down 1 divided by this is your f of d. In that you can take d is common, so that you will get d plus 1 only. So 1 by d you keep as it is, that d plus 1 you are taking to the numerator, and you can apply the formula of 1 plus x whole power minus 1. And after making the formula, you take that 1 by d inside to the brackets, and this is your final answer. Yp you are getting x cube by 3 plus 4x. Remember, I just give you, if d stands for differential operator, which is nothing but d by dx, what do you think about 1 by d? This 1 by d stands for reverse of differential operator. Reverse means it is nothing but integration. So that you keep in your mind, and directly you can just find out your final simplifications. So with this, the problems related to x power k right hand side of your higher order ordinary differential equation is closed. And in the next video session we can take the next one is nothing but it is looking like right side e power ax into v. So with that we can enter into another type of problems, and meanwhile you go through the problems, and if you are getting any doubts or any important questions regarding to ordinary differential equations, in the description part I just give you my WhatsApp group link, so you can mention any type of doubts or explanations. In that I just give you the corresponding explanations. So have a good day. Thank you.